Now guidelines for sequential always block. Only use Verilog non-blocking assignment in sequential always block. So we know that whenever we are modeling the sequential logic, you can say flip-flop. In that case, it's better we'll implement that thing with the non-blocking assignment, because non-blocking assignment will implement the non-blocking assignment will allow us to execute the statements concurrently, which is the property of a sequential circuit, right? So it's better if you need if you're looking for a pipelined output, pipeline logic. In that case, always code that block with non-blocking assignment. Only use Verilog non-blocking assignment in all always block used to generate the sequential logic. So they are telling that suppose in your design there are 10 sequential blocks, means always for all the blocks you use the sequential logic, that non-blocking. Now guidelines for combination always block. Only use Verilog blocking assignment in combination always block. So this thing we know that blocking, because as soon as there is a change in input, you need to find a change in output, right? This is the property of combination. So you can only model that thing with the blocking assignment, because it's not like it's not like sequential. We are waiting for one event, that is clock, and after getting clock only we need to update the output of a register. It's combination is different. As soon as there is a input change in the input, that should reflect in output. So non-blocking is an assignment that will help you to achieve that feature. Place a default next state assignment on the line immediately following the always block sensitivity list. So default next state assignment means usually suppose you take a FSM in which 3 states are there. One is idle state, one is read state, one write state. So idle state we are representing with 2 tick B00. Read state we are representing with 2 tick B1, 2 tick B01, and write state we are representing with 2 tick B10. Okay, so so from idle to read will go if we'll get some input combination. Similarly, from read to write will go if we'll get some input combination. But coming to a question, suppose when your current state is 2 tick B11, which is not defined in that which is not any state, okay, which is not at all a state. In that case, what is your next state output? So in that case, your simulator don't know what he should do, what that simulator should do. So simulator simply recall or retain its previous value. So if it is retaining its previous value, so this is not a property of a combination circuit. Retaining a property is retaining the value is a property of a sequential circuit. So in that case it leads to latch. Okay, so that is why we this guideline is place a default next state assignment on the line immediately following the always block sensitivity list. So after defining the always block sensitivity list, just define next underscore state equal to some default value. You can say that 2 tick B00 idle state or 2 tick BX, any X assignment, in order to avoid the latches. So this default assignment is updated by the next state assignment inside the case statement. Or suppose there is a chance that when current state is idle state or read state, in that case it will first assign 2 tick BX, after that it will override that. Okay, so it's not a problem. So this is a safe coding style. So now there is one more type always FSM coding style, that is one always block style. Okay, so the advantage is simulation efficient, fast to write. So one always block is simulation efficient means you can say that simulation time it will take less, and you can easily write, or fastly you can write. Drawbacks are difficult to debug. So they're telling that debugging is difficult. Output assignment will infer flip-flops. So output assignment will infer flip-flop. Usually output assignment in normal state machine should infer combination, okay, but they will infer the flip-flops. Okay, more likely to code wrongly. Actually it is not a recommended coding style, but we can implement. So, but you will not get an optimized and right result. Output assignment made inside always cannot be melee FSM.